Warm greetings to one and all present here. We are Bhuvaneswari, Mythili, and Keerthika are the students from Stella College and the author for the paper Literature Review on Deep Learning in Autonomous Vehicles. This paper covers details about where the artificial intelligence is being applied in the automobile industry, its benefits, algorithms used with its challenges, and uses in this field. According to the World Health Organization, 1.35 million die in accidents per year worldwide. Researchers indicates that 94% of these car accidents can be tracked back to human error, such as consumption of alcohol, speeding, texting while driving, or even ignoring traffic rules. So the solution to all our problems is automation in vehicles. Companies like Tesla, Audi, Nissan, Mercedes-Benz, BMW, Volvo have already implemented this concept and have reported it to be successful.
Artificial intelligence allows a machine to mimic human problem solving techniques. Artificial intelligence, machine learning, and deep learning are all umbrella terms. There are three types of artificial intelligence. The first one is artificial narrow intelligence, where only one task is focused. This is where our facial recognition, speech recognition, voice assistance, or even our topic driving a car falls under. There's also artificial gendered intelligence and artificial strong intelligence. Our focus for this paper is deep learning. Deep learning is essentially an evolution of machine learning. The basic difference between machine learning and deep learning is that machine learning it learns from experience, and you have to manually input the feature extractors. Where in machine learning, the feature extraction is automatically done and the computation as well in the hidden layers. And deep learning uses neural networks, which is often referred to as deep neural networks, for all of its classification tasks. And the deep learning it requires a lot of training data compared to machine learning. It also requires a lot of training time, but the execution time is less for deep learning comparatively, and it also has a higher accuracy rate compared to machine learning. The fundamental network features for deep learning are unsupervised pre-trained networks, convolutional neural networks, recurrent neural networks, and recursive neural networks. A neural network is that in these deep neural network are similar to that of the human brain, in where the information is transferred from one layer to the other layer, connecting all of these different channels.
So, in our review, the first paper talks about how the government is involved and risk taken. So, the major challenges faced by AI applications to date stems due to the shortage of generalizability to various environments. So, they can face surprising situations referred to as corner cases, that is, if the system have not been trained to handle. So, for example, there are fatal crashes recorded from the trials of Tesla's partially automated vehicles due to the system misinterpretation of environmental conditions that had not been used during testing. And in another paper, it talks about mostly about the safety standards issued by UN regulations. So it established strict requirements for automated lane keeping systems in passenger cars. So it means that once activated, once activated, they are in primary control of the vehicle. However, if the driver wants to make changes in the decision of the system, then it can override such systems at any moment. So in another paper, they talk about the 3D object detection for lidar camera based autonomous vehicles using one shared Oxel-based backbone. So in that paper, they talks about this method first voxelized a point cloud into a 3D voxel grid and uses two strategies to reduce the loss of information during voxelization. So the first strategy is to use small voxel size, and the second strategy is to project the feature of point clouds into RGB images, for example, intensity or height information.
Machine learning is now possible because of the availability of data today, which is gathered from the sensors and internet. The idea is that the computer, just like humans, learn and progresses with time without the emotion. The traffic detection models talked about in this paper use the CNN, RNN, long short-term memory, gated recurrent unit, and Bayesian networks. In the models which we talk about in our paper, uses CNN mostly. So CNN is a neural network, and it has two main parts where the tool it is used to separate various feature for feature extraction, And there's also a fully connected layer which uses the output of the process to classify the images. The parameters for this neural network is length, width, and height of these images. And there are three very basic layers in this neural network, which is the input layer, which accepts the input image. And there's also a hidden layer which does all of the computation work, but as the name goes hidden, it is not revealed. And then there is the output layer which reveals the information. There are also various other layers which are required to classify the information, like convolutional layers, the pooling layers, the activation functions, and the fully connected layers. Um, and in the paper which we've taken video surveillance, it talks about the surveillance and server side processing of the video, and how the images are captured and transferred from the surveillance side to the server side. And they also talk about how about the region of interest, which is only a certain region or a certain subset of an image is transmitted in high quality, which is considered to be useful to save the bandwidth, and how the background in each frame is categorized into different categories such as background, still object, moving object, and the environmental changes. And in the paper Car Detection for Autonomous Vehicle, they talk about region proposal, which is identifying a certain region in an image and what those objects are in those region and to classify them accordingly. They also the another paper they also talk about mission and path planning, which is very vital for driverless vehicles because it helps you to generate a route from your source to destination, and how to ignore all of the objects and all of the interference and maintain a straight path is all discussed in that paper.
In Hedge deep tracking paper, the authors have discussed about the proposed Hedge deep tracking method, which they introduced using CNN. And this method puts together all the CNN, combines several CNN trackers, which results in one single strong tracker. They have used up to 100 image sequences to test the proposed algorithm. They explained how each layer of the CNN captures images. And the last layer captures images that are useful for image classification and not for tracking, as they do not capture the special distance. Whereas the image that are captured in the first layer are suitable for tracking. This algorithm has proposed to take each layer of CNN network, which combines the weak layers of the CNN trackers, and to make one single tracker. So the proposed method was developed after evaluating the performance of the weak trackers, and the algorithm has been explained in the paper with the help of image, which tells us the steps to be followed and the components of the algorithm. And after extracting the features, the image is cropped and resized to fit a target bounding box. After which the outputs from 6 layers, which gives 6 types of features, are mapped, and all the images are resized to the same size, after which the algorithm is implemented, which was found to run at 10 frames per second. Then, after comparing and evaluating, the algorithm was found to be very effective than using a normal CNN. In the next paper, which is vision based detection, the authors have published a new highway vehicle dataset, which has very high definition. And the dataset consists of over 11,000 images. And the proposed dataset images have tiny annotated objects in the image, which provides a great foundation for the vehicle to detect clearly. And this proposed method is of the highway road structure, which is extracted and split into 2 ways. And after applying algorithm, the vehicle objects are obtained, and it is used to obtain the number of vehicles and to judge the driving direction of the vehicle. Next. Robust and efficient. In this paper, they have discussed about the frontal vehicle perception system, which were developed in the European project, and they have focused on perception system and bought 2 approaches with the aim of using both radar and video outputs. To increase the sensor strength and to compensate the weakness, they used sensors, also to get the precise range and estimation. So multiple objects on the road were detected using this, and by using iterations. And by looking at the symmetry and the edges of the object and the symmetry line, they were able to get the output which distinguished between tracks and vehicles and other objects on the road. This algorithm was proved to be very efficient, as the car was able to decide on which lane to take by calculating the distance between the vehicle and each lanes, and also by mimicking the behavior of the vehicle in front of it by using high level sensors and cameras for detection purpose. So deep learning has taken over major subfields of autonomous driving, and research in this field are still going on to improve the performance and efficiency of the vehicle, and new algorithms and methods are being proposed. This leads to the a reasonable conclusion that machine learning algorithms and autonomous vehicles are the future of transportation. Thank you.